Our second to last lesson for this unit, 5.4, Rationalizing Denominator. Our objective for today is that students will be able to divide rational expressions. So two things to recall from our last lesson, 5.3, is that the square root of a times the square root of b, all I need to do is just multiply my a and b and keep my radical sign, and this is when a and b are greater than or equal to 0. The next thing that I just want to touch on before we move into this is our conjugates. You keep hearing this word. Our differences square, a minus b times a plus b. All that is equal to is a squared minus b squared. So let's look at a few examples here really quick. So what do we do when we're multiplying? So I take the numbers, 2 times 3 is 6, and then I multiply 18 times 8. So before I do that, I just want to recall when you're multiplying, it does not matter. I can multiply any number. The numbers under the radical sign does not have to be the same. So this actually becomes 6 times the square root of 144, and we all know 144 is a perfect square, which is 12. So 6 times 12 is actually 72. Let's look at one more example. It says this is an easy one, square root of 4 times square root of 18. So what am I doing? All I am going to do is multiply 4 times 18. There's nothing that says I can't multiply these numbers, that they need to be the same. 4 times 18, we all know 4 8's 32, 4 is 72, and that cannot be simplified. That cannot be simplified into a perfect square, so my final answer is 70, square root of 72. Now for conjugate pairs, now it says the product of a conjugate pair is the difference of square, a square minus b square. When we multiply conjugate pair, the radical vanishes and we obtain a rational number. So whenever we're multiplying conjugate pairs, we'll always have a rational number, meaning a number by itself. So this will be 6 minus square root of 2 times 6 plus square root of 2. I just want to point out, you can FOIL this or do the box method and you will get the same answer. Now the easier way is doing what we said. Take my a, in this case my a is 6 and my b is square root of 2, and I want to square these, so this becomes 6 squared minus the square root of 2 squared, which gives me 36 minus 2, which is 34, and this is my final answer. That's what it means. You will obtain a rational number. This is a rational number, a whole number by itself. Again, you can do the box method or FOIL it out when you do 6 minus square root of 2 times 6 plus square root of 2, but the shortest trick is to, whenever you're multiplying by a conjugate, which is the difference of square, we just square my a term minus square my b term, and this square and the radical sign cancels off. 36 minus 2 is 34. Now this one is x plus square root of y times x minus square root of, where's my square root of y? That's my conjugate. Again, my a is actually x and my b is the square root of y. This becomes x squared minus square root of y squared. So it's x squared minus y, and that's my final answer. Very easy. Again, with this one, we can do box, we can do FOIL. You will still get the same answer right here. Now, the last one we're going to talk about is how to divide rational expression. This is the same thing as rationalizing denominator. So the first thing you want to do is multiply the fraction by the conjugate of the denominator. Very important. Multiply the radical expression, simplify and reduce if possible, meaning putting it in the simplest radical form. So let's see how that works. We have a few examples here. Now, multiply. I'm being asked to simplify these. The first thing I want to do is multiply by the conjugate of the radical. So in this one it says 1 over 3 radical 2. What I want to multiply by is radical 2, which is radical 2 on top, radical 2 on the bottom. I want to multiply across, multiply at the bottom. Anything that has one radical sign in the denominator, I am just going to multiply that by itself. So this becomes 1 times square root of 2 becomes radical 2 over, how do I multiply by this? This becomes 3 square root of 2 times 2. And then I can simplify this as 3 times square root of 4. This can go even further as 2 over 3 times 2. And then finally, I can have this as 2 over 6. When you're rationalizing a fraction, it just means that now there will be no radical sign in my denominator. Square root of 2 times square root of 2 is actually 2 by itself, but I just want to show you how I got this 2 right here. If you type in on your calculator, if you were to put in square root of 2 times square root of 2, you would have gotten 2. And I just wanted to show you the process. You go from 2 times 2, which is 4, and then square root of 4 is 2. All right, moving on to number 18. Don't worry about the numbers. I just took these examples. Now, notice there are two different radical signs in this example. So I want to multiply by the conjugate. So this becomes radical 2 plus radical 3. And again, I am putting that in my numerator as well. So since the bottom is a difference of square, I know this is going to be 2 minus 3. So on a side note, how did I get this? My a is equal to square root of 2. My b is equal to the square root of 3. And I know the difference of square says it's going to be a square, which is the square root of 2 square, minus the square root of 3 square. The radical sign in the square cancels off, and I end up with this. Now in the top, I am going to do the box method. So with the box method now, this is where it gets a little tedious. And I'm going to do the box method here. Let's get some space. Take this out. And I want to do the top using the box method. So you can FOIL this out. And yes, you will have to do this. Square root of 2, square root of 3, plus square root of 3, square root of 2, plus square root of 3. This becomes the square root of 4, square root of 6, square root of 6, square root of 9. And I want to combine these. Square root of 4 is 2 plus square root of 6, 2 square root of 6 plus 3. This becomes 5 plus 2 square root of 6. So my top becomes 5 plus 2 square root of 6. And then I can simplify this as to 5 plus 2 square root of 6 divide by negative 1. And it will give me a final answer of minus 5 minus 2 square root of 6. And that's my final answer. Alrighty, that was tedious, but that's what it is. That is rationalizing denominator. Let's do two more examples before you're off to your own. Number 19, and then we have 20. So, 19 says, I want to rationalize this denominator. So, multiply by the conjugate. Square root of 5 minus square root of 3 over square root of 5 minus square root of 3. Because that's a difference of square, I know this will just be 5 minus 3. Now the top, what would that be? If I do the distributive property, it will be 5 square root of 5 minus square root of 3. This will actually be 5 radical 5 minus 5 radical 3 over 2. And notice I can't simplify this any further, so I will leave this as my final answer. Let's just say these numbers were divisible by 2. I will go ahead and continue with that. Last example, which is a little bit longer, I am going to do multiply by the conjugate. Minus square root of 15 plus square root of 6 on both sides. The bottom, again, I know it's going to be 15 minus 6. And then I want to do the box method for the top. I have square root of 15, square root of 6, that's a plus, square root of 15 plus square root of 6. Now I want to go ahead and I want to FOIL each out to fit in my boxes. So the first one that I want to do is what is square root of 15 times square root of 15? We know that all I'm going to do is multiply these numbers, which is 225. Then I want to do what's 15 times 6 is 90. This is also 90, and then this is square root of 36. Now these are like terms because they're the same radical. So I will end up with 15 plus 2 radical 90 plus 6. 6 and 15 and 6 is 21 plus 2 radical 90. So that's what's going to go on top. And then I want to go ahead and simplify this. This will be 21 plus 2 radical 90 over, now you're going to just simplify your denominator, which is 9. So with this, I know that I can simplify radical 90, which is going to give me 21 plus 2 radical 9 times radical 10 over 9. And this is where all our lessons are being combined. I am left with 21 plus 2 times 3 times 10 over 9. This can go ahead and simplify as 21 times 2 times 3 is 6. Radical 10 over 9. Notice all my whole numbers are divisible by 3. So then my final answer will be 7 plus 2 radical 10 over 3. And this is my final answer. Just to point out, from here to here, I divide by 3. And this is my final answer. Remember, when it's a rationalizing a fraction or a denominator, it means, and you know what, let's make a note of that. Rationalizing denominator means that there will be no radical sign in the denominator. So in just simple terms, whenever you're rationalizing a denominator, it just means that you do not want any radical sign in that denominator. So that's the point of this lesson right here, is to make sure that there is no radicals in my denominators. Alrighty, go ahead and show me what you got on those practice problems. Good luck!